Well, welcome to the end of week 6. In this lecture, I'm going to talk about how to use tiled images inside.
Warren, you in there? Warren! You're recording. Anyway,
yes, Professor Warren.
Greiner and I are going to LA next week to meet with Sony. Are you guys going to be able to hold this thing together?
Yes, we'll do our best. I promise.
And tell Rickster to stop bad-mouthing JavaScript.
Okay, all right.
We are never going to get that deadline for Final Fantasy, get that deal sealed, unless he gets his act together and finishes that port of Code Sculptor to PlayStation 4.
Okay, I'll be sure and tell him.
Oh, yeah, and by the way, I've been looking at those forums. People are complaining. There's nothing in there about Monty Python. Come on, just throw in something. Potted shrubbery, something.
Yes, sir, Professor Warren. He's kind of grouchy. Yeah, Udacity just announced their new class on HTML5 last week, and so I better just go on and do lecture. I'll see you in a second. Well, I hope you enjoyed that. Don't worry, Steven's actually a very nice guy. For this lecture, we're going to work with tiled images. We're going to use these tiled images to organize all the images of the various playing cards you're going to use inside Blackjack. So here I'm sitting inside OneNote, and I've loaded in a tiled image that consists of all 52 cards in a deck of playing cards. Here you can see it's laid out by a 13 by 4 grid. So our job when we're actually building some classes to support drawing cards and drawing hands is to come up with a draw method for a card and a hand. So in this lecture, I'm going to talk a little bit about how to build a draw method for cards that's going to allow us to very easily draw any particular card in the deck. So kind of as a motivation, let's say that we're trying to come here and we're trying to figure out maybe how to draw the 6 of spades. So that's kind of our ultimate goal. As a simpler problem, I'm going to start with just the kind of the issue of trying to draw maybe the ace of clubs. So how can we draw the ace of clubs? Well, let's figure out what the center and the size of the ace of clubs is. I mean, one of the things we notice here, all the images in our tiled image are the same size. Every playing card has the same size. So we're going to leverage that fact when we're trying to figure out how to draw the 6 of spades. So to do that, we're going to define a couple of constants. Let's just do 2 constants. One constant is the size of a card. And I believe for this one it's 73 by 98. And we're also going to explicitly define the center of a card. So we'll call the card center. And let's see, that's 36.5 by 49. So notice if we have card size and card center, we could just supply those as the second and third parameters to draw image, and that would actually pick out the ace of clubs. Now the question is, how can we pick out the 6 of spades? How can we pick out the center and the size of the 6 of spades? Well, the size is really easy. It's just the same size as the ace of clubs. All of our cards here have the same size, so we can just use card size again. But the center requires a little bit more work. So let's sit down and see if we can figure out how to do that. So here's what I'm going to do. I'm going to start off, and I'm going to number all the cards in the first row, numbered 0, 1, 2, 3, 4, and 5. And notice that this kind of 6 kind of sits in the 5th column if we start numbering at 0. And then we can number the entries in a column. So we have 0, 1, 2, and 3. So to get the 6 of spades, what we really need to do is we kind of observe it kind of sits in the, let's see, I guess it sits in the 5th column and the first row, again, starting at 0. So I'm going to define a couple of variables. Let's call this variable I. Define a variable j. And so what do we need to do? What we need to do is, if we could compute I and j, we could do a little math to actually figure out what the center is of the 6 of spades. So let's see if we can do that. So let's see if we can write an expression that does that. So assuming we have I and j, let's go through. Let me get my mouse over here. Let's type in the following. Let's see if we can make an thing for the position of the center of the 6 of spades. So let's call it card. We'll call it card pause. What is it going to be? It's going to be, well, It's going to be some function of the center of the ace of clubs, I and J, and the size of the card. So what do we see here? Well, we notice if we start the center of the ace of clubs, we can stride over 1, 2, 3, 4, 5 card widths, and we get to the center of the six of spades. We start the center of the ace of clubs. If we stride down 1, we go down kind of one kind of card height, we end up at the center of the six of spades. So this expression that we're going to need to do up here is something like card center of 0 plus I times card size. Same thing, card center. Okay, what the heck, we'll go turn these back to lowercase. All right, so now I claim that card position is exactly the center of the six of spades. So now we need to make a draw command that actually draws a six of spades, and that's pretty simple now. We could just go down here and say, we could say something like canvas dot draw image, and we could give it maybe we'll call it tiled image. We need to give it, let's see, the center of the six of spades, that was card, pause. We need to give it size, card size. And then, well, we just give it some extra stuff, which is where we want to have the card drawn. So what we've done here is we've kind of developed some code that allows us to go through and pick out the six of spades. And in fact, in general, what we're going to see here is that we can kind of write code that'll pick out and draw any card in the deck. One of the things that we'll talk about when we actually look at some code in a second is how to figure out where the six of spades lies in this tiled image. So the critical thing to note here is that we've ordered the cards in a specific order here. Okay, we've ordered it ace, 2, 3, 4, 5, da, 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 and then clubs, spades, hearts, diamonds. So inside our Python code we're going to have to figure out how to compute I and J. So let me show you that next in some code in Code Sculptor, and we'll just do a couple of examples. Okay, be back in a sec. Okay, I put together some code to illustrate how you can draw cards. So in particular here I have a card class. This is kind of a subset of what you've got in your existing template. We have the initializer for the cards. It's a rank and a suit. And then we have a draw method here that we're going to call inside the draw handler. So the way this works is I'm going to create a card using the initializer. I start off with the ace of clubs, and we're going to take that and we're going to draw it inside the canvas using this draw method. So what I want to do is actually build this in a way that no matter what I put in for the suit and the card, I actually always draw the correct subimage out of my tile image. So it's fairly straightforward. I defined a couple things to help me here. I have this tuple that corresponds to all the ordering of the cards from left to right, and the ordering of the suits from top to bottom. I have the size and the center of a single card. In this particular case, this is the ace of clubs, this thing in the upper left. And then finally, I have actually loaded in the image here. This is a tiled image. It's sitting out on Google Storage for us. So this is the meat of the code right here. This is what you should look at, and this is what corresponds to what I just talked about. If I'm given the rank of a card, I have to figure out what the corresponding index I was. We did in the previous part of the lecture. So we can use this method called index for a list or a tuple. And what it does is it takes, for example, the string ace, looks up in here and says, oh, that's in position 0, and returns I equals 0. We could take the string C for clubs, look in this tuple and say, ah, C is in position 0, return J is equal to 0. It computes the position of the card in our tiled image, and then we go through and we draw it. And here I just essentially give it some arbitrary location on the canvas to draw. So if I run my code, what I see here is, sure enough, there's the ace of clubs drawn in the center of our canvas. All right, let's check and do it now for the six of spades. So we'll go down here and change this to an S for spades. We'll change this to a 6. And let's go back and look and see what our code should do. Well, it should say, okay, if we have the 6, we'll look up in ranks where 6 is. That's at 0, 1, 2, 3, 4, 5, position 5, just like we talked about. And let's see the suit. That was going to be spades, so that's at position 0, 1. So I would be 5, J would be 1. We would then go through and compute this expression like we talked about in the previous part of the lecture. Now it would give us the position of the 6 of spades in our tiled image. So now when we run this, it's all good, and there it is, the 6 of spades. In fact, I can create any card. This will automatically draw that card. And of course, note, you're going to have to specify what the location is in here. So as you build your blackjack application, you're going to think about where do I want to draw the cards and the hands on the screen. So that's for you to do. Okay, I want to finish off with a little more information about how you can use Dropbox now to actually store your images, your tiled images, and the sprite sheets that you're going to use later in the class. Okay, be back in a sec. So I promised to show you how to host your own images so you can load them into CodeSculptor. Now let me emphasize you're not required to do this. For Blackjack and Spaceship and Rice Rocks, aka asteroids, we're going to provide all the images that you need. But part of the beauty of this class is I suspect many of you will try to go and build your own games and generate your own art. So let me give you a little bit of a walkthrough about how you can use Dropbox to host your own images and sounds. So here I'm sitting at the Dropbox site. A lot of you probably already use Dropbox. It's simple. Just sign up with an email address and a password. Download it. It's very easy to download. Once you've downloaded, you'll be able to pull up a folder inside Dropbox. Mine's sitting here at J. Warren Dropbox. And I've made a demo subfolder here. And I've actually copied the card image inside it. So we can open it up real quick, and there it is. So there's the card image sitting inside Dropbox. And what I'd like to do is get a publicly shareable URL that I can put into my CodeSculptor code and then actually have CodeSculptor go out and download that image from Dropbox into your code. Then you can share your game using your custom images with anybody you wish. So here's how you do it. We simply go to the file, we right click and pull down to the Dropbox menu, and if we walk it out we see a thing that says share link. And after we do that, we'll close the folder here. And what comes up is we see the picture of the image sitting inside Dropbox. And more importantly, it has some information about how to share this. What we're going to do is we're going to use this feature, copy link to this page. So what it's going to do is it's going to actually take the link that it's generated, it's going to copy it onto the clipboard. So I'm going to say copy link to this page. And now what I'm going to do is I'm going to go back to my old program. This is the program that I had built using an image that I'd stored in Google Storage, and I'm going to replace it with the image that I've just loaded inside Dropbox. So what I do is I simply go down here and say Control V. So notice now we've got some kind of Dropbox URL. It ends in the same file name as before. Now this is very important here. If I run this, I want you to watch what happens. It never loads the image. So to use this method with Dropbox, you're required to actually provide an extra extension. So this is very important. Please pay attention. You need to say question DL equals 1. And this tells Dropbox that this file should be downloadable. And so as a result, this allows CodeSculptor not just to view the image, but actually pull it inside CodeSculptor and use it inside your program. So now watch as I run this. There's my image. So my suggestion is remember DL equals 1. It's very important. If you don't, it's not going to work. You're also welcome to use other image hosting sites. There's nothing special about Dropbox. I have one other piece of really important advice. Images, after they've been downloaded once into your web browser, and this has nothing to do with CodeSculptor, it's just a web browser. So once an image is downloaded once, it's cached. What does that mean? It's there sitting in your computer, and the basically any program never goes out to the web to get it again. That's a very nice feature. But one of the dangers is that because the image is cached, if you go out, for example, and play around with a Dropbox or any other image hosting site and change how your images are laid out, when you run the program in your web browser, it may think the image is still there. So here's a very important thing to do. I can't emphasize this enough. If you want to use your own images, and I fully encourage you to do it, you need to take your final CodeSculptor code and test it on a different computer. Because when you run it on a different computer, the images will not be cached, and you'll get to see and make sure that those images will download so that when your peers assess your program, they don't sit there scratching their head thinking, wow, this is really great, but I don't see any images. So let me say it again. Test your code on a different computer if you're downloading your own images and sound. It'll save you a lot of grief. Okay, I'm going to go on and we'll talk about Blackjack next.